section, in this section, we learned that this is a what type of formula right here?
Explicit.
It's based off the previous term. That is a recursive, where you know the previous term, you get to the next term, right? So that's recursive. Great. Actually, not so great. It's a nice pattern. But we need the explicit formula so that you can just create these and not have to actually count up by hand. All right? That's the problem. Pattern, well, it's okay, but then look at the C term over here. Okay? These are all the C terms. Now, anything about 24, 60, 120 that strikes your attention? Okay, 6 goes into all of them. You can see it factored over there, right? So 6 times 4, 6 times 10. Always try to pull out a common factor if you can, right? Try to make the numbers a little bit smaller. Okay, one major problem. 4, 10, 20, 35, 56. No pattern. Nothing. Okay, try 50 different ways. I try advanced college methods of trying to find sequences. Doesn't work. No link. All right? I'm just about to get done.
But
I'll just make them by trial and error and just keep searching for like weeks at a time, and then maybe I'll find another one. But here's the breakthrough. Always nice to get that breakthrough and say, you know what, this actually might work. All right?
just might.
So we got this called up. Okay, so let's start from scratch again. All right? And I tell you what, I want you to focus on the x squared plus or minus 17x plus or minus 60. Look at this one right here. Okay? Look at the b term, which is 17. Did we have any 17s yesterday in our discussion? 17. Seems like there was a 17 in yesterday's discussion.
Was there?
Yeah, it seems like there was. 17.
I don't see it.
Yeah, it was somewhere, there was a triple that had 17 in it.
8, 15, and 17.
8, 15, 17.
Memorize that.
I see. Very good, Stephanie. All right. 8, 15, 17. Okay, here's a wild stab in the dark. 8, 15, 17. That is a 17 right there. That is true. You know, we had a 10 yesterday as well.
Yes, we did.
It was a very commonly used one, which you should know.
6, 8, 10.
6, 8, 10.
This out.
Okay? I might have a link. I don't know. Wait a minute. What's the distance right here? 2. Yeah, that's known as what 2?
Height.
Yeah, height 2. Okay? Pythagorean triples of height 2. There's no way that the only other theorem I come up with in my lifetime is going to be linked to the other theorem that I came up with on Pythagorean triples. There's no chance. Like a 1 in a billion shot.
Yeah.
Well, it's worth trying. What's the next height 2 after this one? 6, 8, 10.
You must have been like freaking.
Oh, let me tell you what. This was something, when I hit this moment, I'm like, oh, this is good. All right? Don't worry about that. Okay. The 10, 24, 26 is just double the which one? Double the, what is that one? 10, 26, 24, 26 is double the other triple that we use.
Double the first one.
5, 12, 13 is just double that one. It's a multiple. Okay. And then we start, no wait, that's 26 right there. Okay, next, you can see the pattern right here, right? 12, 35, 37. 14, 48, 50. You know what? If you do the Pythagorean triples of height 2 from the Wade theorem, which is probably why nobody ever came up with this theorem, because you have to have the Wade theorem first. If you have this, all the, what is the C term? That's the what of the right triangle?
Hypotenuse.
Hypotenuse. All the hypotenuses are matching the middle term, aren't they? Not bad. Maybe this will work. Okay, B terms, 10, 17, 26, 37, 50. Hypotenuses.
Are you eating dinner during this one too?
Not during this one. I'm just sitting around just trying to work on this so I can make these for worksheets.
Is this one that took you 2 hours?
This one, no, this took me a little bit more time. 24 hours probably. Of just nonstop brainstorming.
And the next one.
All right. Then I came up with the theory up here. So we go all right. That is a what type of formula?
Explicit.
That is explicit. All right, that's good. Instantaneously it'll tell you the B term. Okay, that's very nice. You will not have to know that formula. All right,
Good.
so don't worry about that. But it works. It works every time. It cranks out all these right here. The only problem is, remember what we said before, these C terms have. Good heavens, 3 today?
Whoa.
Oh my gosh, son.
Son.
Good heavens.
Some to the class.
Especially you can right in front of them. Oh my gosh. All right. Anyway, you have all these numbers right here. There is no pattern. How in the world can we get this to work? Last ditch effort. Right before giving up. Maybe this will work. All right. If you have a 6, 8, 10 right triangle, let's start with this one. Wouldn't that mean that the legs are 6 and 8 and the hypotenuse is 10? Okay. You know the area of a triangle. What's the area of a triangle?
1/2 base times 1.
1/2. What's the base of this one? 6. What's the height? Okay. Half of 6 is 3 times 8.
Oh my God.
No
I
way.
saw that.
That can't. That can't be true. The area of Pythagorean triple triangles. Let's try the next one. Area equals 1/2. What's the base and the height of this one?
8 and 15.
8 and 15. What's half of 8?
4.
4 times 15?
60. Oh.
You gotta be kidding me. It actually
You had me
works. Is that
freaking
cool?
out right now.
Yes,
crying?
absolutely. You better believe it. I was like, God, this is too cool. And it's based on the other theorem. All right, the chances. So then you do the area of this one, and sure enough, you get 120, you get 210, and you get 336. And it works. It actually works. And then you can see my theorem down there, which is partially based off of 1/2 base times height, and that's the explicit for that one. So basically, when you do the triples of height 2, they also create weight trinomials that all match, every one of them. How about that? And the only trinomials that work like this in this problem on the front page are ones that are associated with Pythagorean triples. That's it. All the rest don't work. After all that randomness and all that searching, there it was right there. Just took some time, 24 hours. All right, there it is. Pretty fascinating stuff. And now, I have an infinite bank in an Excel word spreadsheet that I can use.
Bank account.
No, yeah, I wish. No, and a